All right, let's talk about something that's all around us every single day, but is completely invisible: sound. We're going to break down what it is, how it moves through the world, and most importantly, how we can actually control it to get a little peace and quiet. So let's just start with a thought experiment. What if you could actually see sound? See the waves from a conversation or a song rippling through the air towards you. How would you stop them? Would you try to build a wall? Maybe put up some kind of net? This is the core challenge of soundproofing. And to solve it, we've got to understand what we're actually fighting against. At its most basic level, sound is incredibly simple. It's just a form of energy. When something vibrates, a speaker cone, a guitar string, it bumps into the air molecules around it. And those molecules bump into the next ones, creating this wave that travels out. The best way to picture it really is like dropping a pebble into a calm pond. Those ripples spreading out, that's exactly what a sound wave is doing in the air. But of course, not all ripples are the same, right? Some are big, some are small, some are fast. To really get a handle on sound, we need to break it down into its core properties.
So any sound you've ever heard is defined by these three things. First, you've got pitch. That's just how high or low the sound is. Think of a flute versus a tuba. Then there's loudness, which is pretty self-explanatory. It's the power, the intensity of the wave. And finally, you have timbre. This one's a little more abstract, but it's the unique color or texture of a sound. It's the reason a piano and a violin playing the exact same note at the exact same loudness still sound completely different from each other.
Now, this brings us to probably the biggest misunderstanding in the entire world of acoustics. People throw around the terms soundproofing and sound absorption like they're the same thing. They are absolutely not. They are two totally different goals, and you achieve them with completely different methods. Okay, so here's the simple breakdown. Soundproofing is about isolation. Think of it like building a waterproof, sealed container. The goal is to stop sound from getting in or getting out, period. Sound absorption, on the other hand, is all about improving the sound quality inside the room. It's about taming echoes and reverb, like putting up soft furniture or acoustic panels in a recording studio. So one blocks, the other calibrates.
So if our main goal is that true soundproofing, that acoustic isolation, how do we actually do it? Well, it's not about finding one single magic material. It's about applying a set of core scientific principles. These 5 principles are really the foundation of any effective soundproofing plan.
This is our toolkit for quiet, deflection, absorption, decoupling, thermal conversion, and constrained layer damping. Now, I know that sounds like a lot of jargon, but understanding how they work together is the real secret. Let's start with the one that's probably the most obvious. First up, deflection. This is the brute force method. You want to stop a wave? Put something big, heavy, and dense in its way. When you add mass, like thick concrete or an extra layer of drywall, you create a barrier that the sound wave just doesn't have enough energy to vibrate. It hits the wall and bounces right off. It really is like building a bigger dam to hold back more water. Next up is absorption. Now wait a second, didn't we just separate this from soundproofing? Well, yes, but here it becomes a crucial tool within our soundproofing system. Materials like mineral wool insulation act like a sound sponge. We use them to fill the empty spaces inside a wall to soak up any sound energy that manages to sneak past that first massive layer. This stops the empty wall cavity from acting like a giant drum and amplifying the sound. And now for a really clever one, decoupling. Sound loves to travel through solid things. It's like a highway for vibrations. Decoupling is all about creating a break in that highway. By physically separating the two sides of a wall, for instance, you make it way harder for vibrations to travel from one side to the other. You're basically blowing up the bridge the sound wants to cross.
Okay, this is where the science gets really cool. Thermal conversion. There are certain materials out there designed to do something that sounds like it's out of a sci-fi movie. When a sound wave hits them, it causes friction at the molecular level, and that process actually converts the sound energy into a tiny, completely harmless amount of heat. The sound doesn't get blocked, it literally vanishes, transformed into something else.
Our final principle, constrained layer damping, is basically the superpowered version of that heat conversion idea. This is your secret weapon against low-frequency sounds, like the thumping bass from a subwoofer. You basically make a sandwich, 2 rigid panels with a special damping compound in the middle. When sound tries to vibrate the panels, that gooey layer in between creates shear forces and friction, converting that powerful vibration into, you guessed it, a tiny bit of heat.
So we've got these 5 powerful principles, but what do they actually look like in the real world?
How do we go from these abstract ideas to actual building materials you can go out and buy? Let's connect the dots.
So here's how it all translates. For deflection, you're using mass, so think dense boards like drywall. For absorption, you're using that sound sponge like mineral wool insulation to fill up the wall cavity. To get that decoupling, you'd use things called resilient channels or acoustic hangers to create that all-important air gap. And for that slick thermal conversion, you'd use a special acoustic isolation membrane. You can see they're not competing ideas, they're all parts of a complete system.
And this brings us to the single most important takeaway from this whole thing. After seeing all these different principles, you might be tempted to ask, okay, so which one is the best one? And the answer is, that's completely the wrong question to ask.
So here's the bottom line, the most important thing to remember. There is no magic bullet. Effective soundproofing is never about a single product. It is always, always a system. A truly quiet wall will use mass for deflection, insulation for absorption, and some form of decoupling to stop vibrations. Each layer tackles the problem in a different way, and together they create a result that is so much more powerful than the sum of its parts. It's all about the layers.
So we've gone from a simple ripple in a pond to a sophisticated, multi-layered system for controlling acoustic energy. You now have the fundamental toolkit. So the question isn't just about how to stop a wave you can't see anymore. The real question is, with this knowledge, how are you going to choose to shape the soundscape around you? That's it for this one.